following pictures are dedicated to an automatic plant for the production of double-layer tiles for indoor use, either for private houses or public spaces. The plant is pointedly able to produce any type of double-layer tile, either for indoor and for outdoor use, and it can be equipped with any size up to a maximum of 70 by 70 centimeters. Ocem and Cassani companies are pleased to present this video clip to show to all the interested clients all aspects of an automatic plant, including all the possible producing capabilities it offers. The plant in this video clip was developed by Ocem and Cassani in several steps between 1995 and 2005 on the premises of the Scensi company in the Rome province, with the active assistance of the Scensi company itself. In the layout of the factory, it is possible to see the several parts composing the whole plant. The mixing plant for the preparation of the first layer wet mixture used in traditional tiles or cement tiles. The mixing plant for the preparation of the second layer semi-dry mixture. The rotating press at 7 stations OPA 1440 with a pressing power up to 520 tons. The automatic line Linearelle Cassani to move the fresh tiles from the press to the steel pallet and to move the cured tiles from the steel pallets to the deposit path. The curing chambers, in this case by steam. The polishing line consisting of a 6-head polishing machine 3006. The manual palletizing. The heat shrink film wrapping. The plant's control area with 2 control boards. The plant is fully automatic until the polishing operation, and it can be controlled by means of detail boards through which it is possible to control any phase of the process up to any single operation, which can also be done manually if necessary. Every plant control is developed upon a highly performing and very reliable PLC Siemens S7 software that also allows to check operation sequences and the search for faults. The control and checking boards can be set in the same area or platform in order to simplify the process control and any possible intervention. The Ocem press is fitted with TESEO data transmission control. Therefore, Ocem can real-time check every operation and any possible malfunctioning of all its presses around the world, from its premises in Italy, and thereby correct them. We can now follow the several production phases step by step. The first layer mixing plant is composed of a group of 3 hoppers to store 3 types of different granulates, while the calcareous sand is stored in a silo. A load cell weighing conveyor belt that moves the raw materials from the hoppers to a second band and through this one to the mixer. A barrel mixer to mix all components with water and obtain an homogeneous mixture. During the preparation of the mixture, fluidifiers can be used to render it softer, using less water. Cement is contained in the silos above the mixer, and it is weighed before being inserted into it. The mixing plant allows the preparation of many different recipes, all of them stored on a PLC memory. The so prepared mixture is then transferred to the first layer doser of the press by means of a conveyor belt. The second layer mixing plant is composed of a steel hopper containing stony material that cannot be stored in silos, while the calcareous sands are stocked in the silos we are seeing right now. The stony material and the sands are weighed on a weighing band and then transferred to the 250-liter planetary mixer that homogenizes them with a little water and then transfers the mixture to the second layer hopper through a conveyor belt. Once the two mixtures, constituting the two layers of the tiles, are ready in the two distributors of the press, let us see how the press operations go through. The dosing of the mortar into the molds is done by adjustable dosing cups, wide in diameter and low in height, in order to facilitate the discharging of the mortar even in hot and dry weather. The doser is rotating and hydraulic controlled with 3 long-life cast iron and chrome steel plates designed for minimum mixture loss. In the dosing station and in the 2 following ones, the mold receives a strong vibration with adjustable intensity in order to let the mixture flow well and evenly distribute into the mold, with a 15 mm height in this specific case. An optional device called superior spreader, like the non-working one shown here, ensures in any event that the mortar is perfectly distributed into the molds before the second layer is poured. In the 4th station, there is the hopper for the second layer, which is poured over the first layer. This hopper is of old conception, so it does not have the extractor conveyor of the mix, and it is fitted with just one anterior scraper. Nevertheless, it can uniformly spread the second layer without causing any conicity in the tiles. The new type of hoppers are fitted with double scraper and extracting conveyor. The 5th station is used for the first pressing operation. Pre-compression favors a better settling of the materials in the mold, especially when dealing with peculiar materials, and a better water flowing from the first to the second layer. This way the final pressing operation becomes faster, especially for high thickness products. The first pressing operation also allows an efficacious cleaning system to wipe the exceeding material off the mold surface using a scraper set between the 5th and the 6th station. In the following station, the final pressing operation takes place. The great pressing power, up to 520 tons, grants a very good compactness of the materials. It is possible to install an hydraulic valve controlled by a logical function that checks and optimizes the pressing operation using several fully adjustable ramps. The final station is dedicated to the unmolding of the pressed product. In this plant, a small steel pallet for the 8 tiles is used. This pallet is collected from automatic line by the extracting carriage, and it is put under the press mold and then back on the line to be stored in stacks with the others. The last generation automatic lines mainly use a vacuum-operated takeoff device that transfers the fresh tiles from the press extracting carriage to the steel pallets remaining on the line. All the carriage movements are programmed and their speeds controlled by the inventor. Security controls keep watch on the progression of the operation. All OCM presses are equipped with security systems to grant the complete automation and to avoid damaging the machines, which would result in long work stops if all movements haven't been appropriately executed. Similar checks also exist on the automatic Cassani line to make sure that all movements are correctly done by the pallets and therefore avoiding malfunctioning and stops. The automatic Cassani takeoff device is a horizontal deposit line, combined version that connects the press to the polishing calibrating line. It handles galvanized metal pallets in several sizes, depending on the tile sizes and on their number for each mold. The upper surface is made of metal profiles on which the tiles are placed. The distance between the metal profiles is decided on the basis of the product sizes to offer tiles best support. Anyway, a galvanized steel sheet can also be a fine support if the tiles are many at each pressing operation, or if there are many different mold sizes installed on the press. The pallets run on the line and, once they have received the fresh cement tiles, they are transferred to the stacking station, where they are piled up in stacks of 20 or 30 according to the weight of the products. Once the stack is built up, it is automatically transferred to the collecting station, from which the forklift takes 2 stacks at a time and stores them into the curing chamber according to a fixed program. Later, the forklift will collect the 2 stacks of pallets containing cured tiles from the program curing cell and will transport them to the automatic line station where the pallets are unloaded. Loading and unloading operations occur at the same time. While a pallet is uploaded with fresh tiles, another coming from the curing chambers is unloaded of the cured tiles. The steam curing operation takes 1 day, as in this case. Otherwise, if naturally cured, it can take up to 2 days. In today's lines, also the cured products are collected by a vacuum-operated takeoff device and placed onto the path to be forwarded to the polishing line. In this case, the unloading is performed by a clamp device that simultaneously reverses the tile of 180 degrees. Tiles proceed in the path toward the Cassani 6-head polishing machine, which grinds the tiles to a standard final result. Eventually, after the polishing operation, the tiles are manually collected to be placed on wooden pallets. Once the tiles are collected and palletized, they are capped with a low-density polyethylene wrapping to protect them during the transportation. The cap is made by the machine itself from a textile roll of a determined height. The machine opens it, lowers it to the pallets, and then releases it, so that, by effect of its elasticity, it returns to its prime dimensions, clamping the pallets. All these operations are automatic. The so-wrapped pallet passes by the collecting path to be stocked on the outside area. Osem and Cassani hope to have clearly showed the process for the manufacturing of terrazzo tiles and would like to thank the Sensi company for their assistance in the production of this video clip.